Hi everyone. First of all, massive thank you to everyone that's supporting the ProForge 5 and everything we're doing with the tool changing technology at MakerTech. We're constantly looking to push and evolve past what's currently possible in the market whilst keeping everything as open and transparent as possible. So without much further ado, let's just get into this raw look at the machine. So let's start at the slicer. So the ProForge 5 is compatible with most open source slicers that are capable of running multiple tools. So that's Orca Slicer, which is what we've got open. That's Orca Slicer, and I think a few others. So with Orca Slicer, we will have profiles ready to go. So you pretty much just download them, upload them onto your Orca Slicer, and you're good to go. We're running PLA right now, and we're running the standard 0.2mm layer height settings. So if we go into speed here with the standard settings, these are the settings that we're pretty much recommending as defaults. You can sort of pause the video and take a look at what they are. So these settings are what we would recommend using on a regular basis. You're pretty much guaranteed to get a good print, to get a safe print with these settings. And we've got this 5-color Benchy loaded up, and within within Orca, you can assign different parts of the models different extruders, i.e. colors. And behind the model, what we have here is not a purge tower, but a priming tower. So the difference between purging and priming is that you're not wasting as much filament. You're not pushing out filament that was previously in the hot end. What you're essentially doing is just priming the new hot end for printing. So what this prime tower does is it essentially prevents any blobs or any sort of oozing from affecting the quality of what you're trying to print. So let's go ahead and slice this. And so we have a printing time of 2 hours and 20 minutes. And we've got this, we've got our slicer connected directly to the machine. So we can just go ahead and hit upload and print. But before we do, let's take a look at the printer itself. So here we have in person a raw look at the machine. So inside we have 5 tool heads, as you can see. All neatly mounted, all neatly cable managed with these spring steel guides. And then in the rear we have this exhaust fan. So this fan is designed to pull hot air out of the printer. So when you've got your enclosure set up and you want to print low-tech materials such as PLA, you can do that with the enclosure doors shut. That fan back there will exhaust out the hot air and prevent the chamber from getting too hot. This here is a fume filter. So this filtration system essentially recirculates air within the chamber and then passes it through these carbon pellets here. And that essentially keeps the air nice and clean. And then here we have a PTC heater. So this heater here essentially helps get the chamber up to temperature for printing higher temp materials such as ABS, your ASAs, that sort of thing. And yeah, so let's just take another quick look at the machine itself. And then what we've got it on are these caster wheels, as you can see here. So these are really nice heavy duty industrial size wheels, and they make moving the machine really nice and easy. So let's hit upload and print and get this print started. So the first thing the machine does is it homes the X and Y axis, and then it will bring the bed up to home Z. So we'll let it heat up the bed now, and we'll come back to it in a couple of minutes. So with the bed now at 60 degrees, the printer will essentially tram the bed. And then it will do a scan of the area, of just the area that it will be printing on. So we'll now go ahead and tap the bed with the nozzle to get an exact Z offset. So it's just homing now, and then everything goes, done the tap procedure. So now we've got the Z offset. Now we just wait for the printers to all heat up to the printing temperature, and once they reach that, the print will start. So as you can see, with that tap offset feature, we get a really accurate first layer. There's no need to tweak anything. There's no need to adjust for any temperature deviations, any thermal expansion or anything like that, because the bed is being physically tapped by the nozzle. Get a really accurate first layer, and that coupled with the bed scan that the probe does, you essentially get that right the way across the entire platform. So we'll let it lay down some layers, and we'll come back to this print a little later once it's laid down a few different colours. And again, in person, it just looks absolutely phenomenal, this machine. It's kind of hard almost to do it justice on camera, but in person it just looks incredible. So we're back now, approximately an hour into the print, and see for yourself that quality is really nice. The layer alignment is also just fantastic. And show you guys now what it looks like swapping heads and how quickly and effortlessly it does that. So you can see there when it primes, it only takes a couple of seconds to do that. And the amount of material inside that white tower as well is minimal. Right, so we'll come back again once the print is finished and take a closer look at it. So here we are with the print finished. And just take a look at the quality. And then this here is the waist tower.